company is called Flywheel Supply. We're stationed in the Midwest and Northwest Iowa. We produce a wide range of parts for the antique application market, as well as steam and boiler controls, valves, and gauges for both the industrial and some government type of applications. I saw a lot of labor involved that could be streamlined with a robot. The only way that made sense for us to put a robot on a machine tending application was to be able to do randomized bin picking. If an operator is to stand there and line the parts all up for a robot to pick them, it would defeat the entire purpose of using the robot to begin with. The cobot has to be able to pick a wide variety of part numbers. It's got to be able to pick up oily parts. It's got to be able to pick up randomized parts just laying in a bin. And then it's got to accurately place them so that the machine can process them in a timely and efficient manner. After the robot picks the part, it places them in the jaws, and then the machine indexes around to multiple stations to do multiple tasks. The tasks include drilling, chamfering, threading, a wide variety of applications. One of the biggest advantages to Actinav is that we're able to do a bin pick with suction. We then verify suction in the logic of the program. Then we represent the part to the scanner if we don't have a part present at that point, or if the image sensor noticed the part has changed in position at all and would make an unplaceable part, we then place the part in a reject bin. So we're doing validation checks throughout the placement routine to verify placement and make sure it's going to hit the target in the angle and method we need it to for a more accurate placement. The biggest advantage to Actinav is that it can just take randomization of parts being dumped in a bin, and as the bin gets low, a person can just come by and dump some more into the bin, and it'll keep picking parts. It doesn't have to be reset, it just keeps picking parts. The biggest cost savings of the cobot will be the cobot could run lights out 24 hours a day around the clock without stopping, and will therefore be able to outperform a human who can only work 8 hours a day. And that one person that used to run that machine can now become a more skilled, higher paid, more diverse worker, and maybe babysit a work cell with 4 or 5 applications happening that they used to only be able to do, one.
When Zach first came to me about the robot, I thought he was kind of crazy at first, but then he kind of talked me into it, realized that it was going to save us a bunch of time. Just push a button and let it go do its job.
UR cobots are fairly friendly to move around. We opted to build a subplate that we mounted the cobot to so that we can precisely realign the base from one machine to the next. We integrated it with one of the welders, which was a fairly simple and straightforward process. One of the really nice advantages of the UR robot and the software is you're able to take a CAD file and output a G-code toolpath like you would use on a mill. By creating multiple planes inside a polyscope on the software, you're able to easily move certain features of your weld around to adjust and tweak to dial in exactly where and how you want the weld to lay. In our TIG welding application, we went from a minute cycle time to 14 seconds part to part. That's 14 seconds counting cycle time and an operator loading and unloading. In the next year, I'd like to see 3 to 4 more cobots go in to our shop to integrate the next machines down the line, so that as the product comes off of one machine, it can be handed down to the next machine and the next machine and become assembled product, and then even maybe packaged at the end.
Having the robot has decreased the back orders and improved the customer satisfaction because stuff gets done faster, and I've had people call me on the phone and say, wow, I wasn't expecting that. You said 2 weeks and here it is.